Hi, fourth graders. This is lesson 85. We're going to talk about multiplying by 10, 100, and 1000. Okay, so today let's take a look at that. When we multiply with a number that is a 10, 100, 1,000, 10,000, 100,000, doesn't matter, we pay attention to the amount of zeros and we simply attach them to the end of a simpler multiplication problem. Okay, we know that if we have 56 times 10, we're going to take 56 plus 56 plus 56 plus 56 until we get 10 of those in there. However, when we look at this, we can also work on it with the idea of looking at where the zero's placed. Now, a lot of your parents probably have learned about kind of taking off the zero and adding it back on in the end, but maybe not rewriting it as such as it looks in the picture like we have right here. Okay, so we have 56 times that 10. So we drop the zero down. I'm going to move these up just a little bit so that we have a little bit more space to see them. Okay, let's move that one over here then. Okay, so we're going to take them and we're going to look at what do we do, how do we deal with these zeros at the end. All right, so I have 56 times 10. I have the zero hanging off the side, so I put the zero at the end of my problem. Then all I do is look at 56 times 1. And if I have one group of 56, I have 56. I could also do 1 times 6 is 6, 1 times 5 is 5 to get those two numbers. When we look at the next one, it's the same situation. I have two zeros right here. I wrote them off to the side and I just put my zeros in place where they belong. And then now I have 1 times 2 is 2 and 1 times 8 is 8, or you can think of it as 82 times 1 is 82 and drop your two zeros to the side. Okay, we have the same thing here. 93 times 1 is 93, and then I have 1, 2, 3 zeros, so I put the 1, 2, 3 zeros onto the end of that problem. Okay, now the next page here, I want you to try these out. See what you can come up with. So 524 times 10. And then 729 times 100, 3,296 times 1,000. Now in each of these situations, we're hoping that it becomes a mental math process. And in doing so, you're just, like we said, adding the zeros on and things like that. So let's see if we can do these and have some success with them. All right, it's written out the way I would want it to. The zero's off to the side. So we're going to drop our zero into place so we don't forget. And then we have the 524 times 1, or we can do 1 times 4 is 4. 1 times 2 is 2. 1 times 5 is 5. So we get 5,240. If you look at it, it's the top number and a 0. Okay, how about the next one? All right, we're going to drop those zeros down. 1 times 9 is 9. 1 times 2 is 2. 1 times 7 is 7. Again, because it's timesing it by 1, 729 times 1 is definitely going to be 729. And we drop our two zeros down. The top number and the two zeros. How about this one? The top number, 3,296, with 1, 2, 3 zeros in it. And then of course I should put my commas in it because it helps me better to understand what the number would say. So now this is easier to see that this is 3,296,000 total. That's it. Okay, so we have those zeros at the end, depending on where their placement is. When you look at a problem like this, 100 times 68, we might think, okay, I'm going to write it 100 times 68. Okay, no. we don't need to put our mental stress through that. We can write it like I have it down here because of the commutative property. We can flip-flop them. We put the 68 on top, the 100 at the bottom, and we drop the zeros off to the side there. So now we have a 0 here, a 0 there, and 68 times 1, which would give me 68. And I get 6,800. Okay, so just to review, we want the 110, 1,000, we want that at the bottom. We want the zeros hanging off to the side, and then that basic problem right there for us to finish off. And because we're multiplying by 110,000, that type of thing, it's always going to be the number times 1. So it makes it for a nice problem for that. On your assignment for today, you have a few of those problems on there. Okay, I just want to give you some hints on different ones. When you're looking at number 7, it has 2 parts to it. 1/4 of the 48 gems were rubies. How many of the gems were rubies? And they say draw a picture to solve this problem. That's the first part. Okay, so basically you can make a table, you can make those squares. If you're going to do that for that type of problem, 1/4 of the rubies, so you would make your box like this with 4 sections, and then you're going to do your division, your 48 divided by 4, and then you know how many is in each section. And then it says what percent of the gems were not rubies. So it says 1/4 was, but this many were not. So what fraction is that? And then change that fraction into a decimal. When you do that, I want you to think about if I have 3/4 of a dollar, how much do I have? And then put that percent sign after that. Okay, so if you have 3/4 of a dollar, how much do you have? And then make sure you put the percent sign at the end instead of like a cent sign. And that's for 7A and B. Okay, for 8, you do need to do a fraction, and then for B, you have a decimal and the words. So there's 3 things in number 8, so make sure you put them all in there, okay? When you're doing the exponents, when you're looking at exponents, remember this. If I have 3 to the 4th power, it is not 3 times 4. It is 3 times 3 times 3 times 3. Okay, this tells me how many times I need to write the number down, and then I multiply that number. So what I do have is 3 times 3, which is 9, times that by 3, which gives me 27. That's this 3. And then I have one more, times it by 3, which gives me 81. Okay, so when you're looking at that, the other thing you could do is something like this. If you have 3 times 3 times 3 times 3, is you can do 3 times 3 is 9, and then you can do the other 3 times 3 is 9, and then multiply them together to get that 81. Okay, so that's that exponents. You're going to need to know about exponents for number 20, and we talked about square root before. As you're doing your work there, make sure you have dollar signs and decimals and different ones. Remember, if you have something like this, 5M equals $3.50. This is the same as 5 times M equals $3.50. Okay, so that's just because X can look weird. It could, somebody might think this is 5xm, but it's not. It's 5 times m. All right, so that's, just remember that when you're doing things like number 19 on your work. Okay, going through for the rest of that, just a few little things here. When you're looking for write a formula to represent the relationship. You can say the number of meters times this equals the number of centimeters. Okay, that's the type of thing we're looking for number 27A. And then the rest, just make sure you read all those questions carefully, that you read it fully, and double check work when you get a chance. Okay, so hopefully, again, your lesson about multiplying and dropping those zeros down makes sense. And I will see you tomorrow for our practice test.